All right, exam 3 for Physics 101, covering chapters 5 and 6. Which of these following is a conservative force? Remember, conservative forces conserve energy, and the only forces that conserve energy truly are those that are field forces, and that would include gravity. Friction is a contact force. Similarly, air resistance is a contact force. Those are both non-conservative, and they do not conserve energy. And convection isn't even a force at all. We haven't studied that yet, but it's a mode of energy transfer. A massless spring initially compressed by a displacement of 2 centimeters is now compressed by 4 centimeters. How is the potential energy of the system changed? Well, I know that the potential energy of a spring is 1/2 kx squared, and I'm going from 2 to 4, so I'm doubling x. I get a factor of 2 in x. That means I'm quadrupling the potential energy, so C is the answer for 2. 2,000 kilogram car can accelerate from 0 to 30 in 6 seconds. What is the average power needed to achieve this acceleration? Well, power is equal to energy over time. So I just want to first find how much energy does it have. That's going to be the kinetic energy, which is 1/2 mv squared. That's a half of 2,000 kilograms times v squared, which is 30 meters per second squared. So yeah, so that's 900,000. That's in joules. However, 900,000 is not the answer. We want to know the power, and so that's going to be that energy divided by the time, or the time here is 6 seconds. Will be the power, and that's going to be 150,000 watts. Tractor pulls a log with a mass of 500 kilograms along the ground for 100 meters. The rope between the tractor and the log makes an angle of 30 degrees and is acted on by a tensile force of 5,000 newtons. How much work does the tractor perform in this scenario? All right, so I have this log. I'm pulling it with a rope that is 30 degrees and has a force of 5,000 newtons. And I want to know the work. And when we pull this, by the way, for a displacement of 100 meters, my work is FD cosine theta. Here I give the mass of the log, but you don't really need that. That's relevant in this case because I already know what the force is. It's 5,000 newtons times 100 meters times the cosine of 30. $433,000, which is 433 kilojoules. Weightlifter lifts a 275 kilogram barbell from the ground to a height of 2.4 meters. How much work has he done in lifting the barbell? And then how much work is required to hold the barbell at that height? Well, for the first part, we can find that the work is just equal to the force times the displacement. There is no angle, so I'm just going to leave off that cosine theta. The force is the weight, mg, times d. So that's 275 kilograms times 10 times 2.4 meters. And that is equal to, I think, 6,600. Yeah. 6,600. So that's the amount of work required to lift it, so I can get rid of those two. And then what about to keep it there? Is it either 0 or does it still require 6,600 joules? All right, well, you're not having any displacement just to hold the barbell there. So there's 0 work required. So B is the right answer. 40 kilogram block is resting at a height of 5 meters off the ground. The block is released and falls to the ground. Which of the following is closest to its total mechanical energy at a height of 2 meters, assuming air resistance is negligible? All right. It's meant to be a simple problem. I have this object. It's initially at rest up here. So up here, V is equal to 0. And then it drops. Right? It falls down. And then I ask, at 2 meters, at this height equal to 2 meters, what is its total energy? That is, what is the sum of its kinetic energy plus its potential energy? However, because it only has conservative forces acting upon it, I can ask what is the energy at any position. So I can also find the energy right here. And at this point, it only has potential energy. That's equal to mgh, 40 kilograms, 10 meters per second squared, times 5. That's 40 times 50, which is 2,000. So number 6 is C. You could have gone through and you could have solved for the velocity at 2 meters, and then you could have added up the kinetic energy and the potential energy, but then, of course, you would just get 2,000 joules. So the answer here is C for number 6. When an increase in speed doubles the kinetic energy of a moving body, its momentum does what? Remember, kinetic energy is 1/2 mv squared. Now, in order to double my kinetic energy, that means that I have to have √2 increase in my velocity. In order to double the kinetic energy, I have to increase velocity by a square root of 2. That means the momentum, which is the product of the mass and the velocity, is going to increase by √2. If I increase the velocity by √2, the momentum will increase by √2, which is less than 2, so A is the right answer for number 7. When an increase in speed doubles the momentum, its kinetic energy does what? So this is similar. So if my momentum increases by a factor of 2, that means my speed is increased by a factor of 2. And then the kinetic energy is 1/2 mv squared. If V increases by a factor of 2, the kinetic energy increases by a factor of 4. So C is the right answer because 4 is bigger than 2. 800 kilogram car is traveling at 12 meters per second when the brakes are applied. Car skids to a stop in 4 seconds. How much kinetic energy does the car lose in this time? I just want to know the kinetic energy, 1/2 mv squared. That's 812 meters per second. I get 57,600, 58,000 joules. That's 5.8 times 10 to the 4. So number 9 is D. Particle on a frictionless track is shown here. Particle is initially at a height of 10 meters and is not moving. It's released. What is the speed at point B, which is 2 meters high, 2 meters above the ground level? So I want to just look at my energies. Now up here, my potential energy equals mgh. My kinetic energy equals 0. Over here, my potential energy equals mgh2. And my kinetic energy equals 1/2 mv squared. So I say this energy equals this energy. That is to say, mg, I'm going to go and put in the h here of 10 meters, equals to mg times 2 plus 1/2 mv squared. And then I go about solving this for v. I cancel out those masses. They all go away. I can subtract 2g from both sides, and I'll get 8g on this side, because that's 10g minus 2g is 8g, and that's 1/2 v squared. So multiply both sides by 2 to get rid of that 1/2, and then I take the square root of both sides, and I find that v is the square root of 16g, or the square root of 160. Which is, well, among these, it's going to be 13 meters per second. Right, you know, it's not 10, that would be 100. It can't be 9, that's 81, so it has to be 13, and actually it's 12.6. All right, and the next question was similar. What is the speed of the particle at point C? Okay, so a similar thing. I am now going to take the energy here and set it equal to the energy here, where the potential energy equals 0 and the kinetic energy equals 1/2 mv squared. All right, so get back up here. So the potential energy equals kinetic energy, right? Because at the top, kinetic energy is 0. At the bottom, potential energy is 0. That's mg times 10 meters equals 1/2 mv squared. So those masses go away, and now I solve for V. Multiply both sides by 2. Gets rid of that half, and then I take the square root of both sides. So that's the square root of 200 is V, which is 14. For number 11 is 14. These 4 blocks are all moving to the right. Which of these forces is doing 0 work on the block? Okay, this one is doing negative work. This one is doing positive work. Negative because the force and the displacement are in opposite directions. Positive because the force and displacement are in the same direction. This force is doing some negative work and some 0 work. Okay. And so that leaves us with this one. In this one, the force is perpendicular to the displacement, and so the work is 0. If you forget, you can go back to our equation, FD cosine theta. All right, here, theta is equal to 90 degrees, and the cosine of 90 degrees is equal to 0. So that means that the work is going to be 0. A spring has a spring constant of 100 newtons per meter. The mass of the block is 2 kilograms. You compress the spring by 10 centimeters, as in this figure. The spring causes the block to move to the right, and then the block leaves the spring and continues along a frictionless surface. What is the velocity of the block after it leaves the spring? Right. It has a certain amount of kinetic energy here, 1/2 kx squared. After it leaves, it only has, it has a certain amount of potential energy, 1/2 kx squared. That's elastic potential energy. And then after it leaves the spring, it only has kinetic energy, 1/2 mv squared. Because these are conservative forces, I can say that this energy is conserved, and so I have 1/2 kx squared equals 1/2 mv squared, and then I solve for v. So see, I can get rid of the halves there. I divide both sides by m. That gets rid of that, and then I take the square root. So it's the square root of kx squared over m. Now you got to be careful here. That's 100 newtons per meter. Be careful because x is given in centimeters, but that's 10 centimeters is 0.1 meters divided by the mass of the block, which is 2 kilograms. And I see the square root of 1/2, which is 0.7. D is the right answer. 2 trailers, X with mass 500 kilograms and Y with mass 2,000 kilograms are being pulled at the same speed. What is the ratio of their kinetic energy to Y to that of X? All right, they have the same speed. I'm looking for their ratio. The energy of Y, 1/2 m Y V squared over 1/2 m X V squared, or you can write it like this if you like. I prefer this. And then we'll write it in that ratio form. Since our speeds are the same, these are going to cancel and the halves cancel. So we're really just looking at a ratio that's dependent upon the ratio of the masses. The Y has a mass of 2,000 kilograms over 500 kilograms. That simplifies to 4 over 1, or writing it ratio form of 4 to 1. All right, a 1 kilogram block is traveling to the right at 3 meters per second. It collides with a stationary 2 kilogram block, which then moves at 1 meter per second to the right. What is the final velocity of the 1 kilogram block? Okay, so I have a 1 kilogram block traveling 3 meters per second initially, and then I have this 2 kilogram block with 0 velocity. All right, my momentum here then will be m times v, which is going to be 1 kilogram times 3 meters per second, or 3 kilogram meters per second. All right, in my final state, the 2 kilogram block now is now traveling with a velocity equal to 1 meter per second. And I want to know what is the velocity of this 1 kilogram block. All right, the P final then will equal the 1 kilogram block times V plus the 2 kilogram block times its V, which is 1 meter per second. Now, these momenta have to add up to equal the same. So I have 3 equals 1v plus 2 times 1. So subtract 2 from both sides. So v equals 1 meter per second. A force of 100 newtons acts on a 100 kilogram boulder for 2 seconds. The same force acts on a 1 kilogram stone for 2 seconds, which experiences the larger change in momentum. F is delta P over delta T. I have the same force acting for the same amount of time, so they'll both have the same change in momentum. So C is the right answer for 16. Alex throws a 0.15 kilogram rubber ball. It bounces, or its speed just for impact is 6.5 meters per second, and just after is 3.5. So I have this ball, it's going down at negative 6.5. And then afterwards, it's coming back up again at positive 3.5. This is V initial. This is V final. It lasts for 1 second, 0.1 seconds. What is the force that acts on this ball to cause this change in speed or change in velocity? That's going to be delta P over delta T. M times VF minus VI, 3.5 minus negative 1.5 divided by delta T, which is 0.1 seconds. Now I see I know my mass actually is 0.15. That's 0.15 times 10, 1.5 over 0.1, which is equal to 15 newtons. So A is the right answer. Which of these statements is true? Well, energy is a scalar, so that's not true. This one's true. Energy is a scalar, momentum is a vector. This isn't true. They're not both vectors and they're not both scalars. So B is the right answer for number 18. At a raft with a mass of 100 kilograms is drifting at 4 meters per second. A person drops onto the raft from a tree branch over the river. The person has a mass of 100 kilograms. What is the speed of the raft after the person jumps on? Okay, the raft has a certain momentum, pi. That will not change. So it will stay the same at pf. I'm not exerting any forces to cause it to move forward at a faster rate. So the momentum shouldn't change. However, the mass of this object is changing. But this is a little bit different than some of the other problems that we've had, because previously we deal with objects changing speed or velocity, but here we're actually changing the mass, because I have this raft, it's moving along at 4 meters per second, and then all of a sudden I double its mass. So what's going to happen to its speed? Well, its speed is going to decrease by a factor of 2. Let me show you. So here, this is the initial mass, which is 100 kilograms, times the initial speed, which is 4 meters per second, equals to the final mass, which is 200 kilograms when you drop this person on, times VF. Divide both sides by 200, and I find that VF is equal to 2 meters per second. So you increase the mass by a factor of 2, you decrease the velocity by a factor of 2. Which of these is energy conserved? Okay, well that would be in elastic collisions. Certainly not that or that. So it's C, not D. Gas particles colliding, they don't actually touch. They have field forces in play, electrical field forces. And an inelastic collision is one in which only momentum is conserved. So going back to number 20, these would both be inelastic. Anything that's not elastic is an inelastic collision. I have this ball that's hit, it's going 6 meters per second, and then it's going 14 meters per second. What is the magnitude and the change of the momentum of the ball? Well, we're going to need to be very careful with our signs. Let's say that the ball is initially moving in this direction. That would be -6. And then you hit it with a bat, and now it's moving in this direction at 14 meters per second. So VF is 14. So delta P is equal to M delta V. This is my change in momentum, 0.12 kilograms. 14 minus -6. That's 20. That's 0.12 is 2.4 kilograms for number 22. A system of particles has an energy of 0. I remember Energy is a scalar quantity, so if that's equal to 0, since you're not dealing with vectors, energies can't cancel out. Like you can't have two objects moving in opposite directions and say that they have 0 energy. So if they have an energy of 0, that means they're not moving at all, which means that the momentum is also 0. 23 is A. Which of these has the largest momentum? All right, remember, momentum is the product of the mass and the velocity. So the momentum of this one is going to be 3 mv. This would be 4 mv. This would be 6 mv. And this would also be 6 mv. So the one with the largest will be these two, which is B. For 24. A very similar question, but largest energy. Remember, energy is 1/2 mv squared. So now we're going to have to square that coefficient. So I'm just going to say, I'm just going to take this coefficient times the square of this coefficient. So that would be 3 times 1 squared equals 3. The reason I'm doing that is because I imagine I put a 3 here and a 1 here, and it changes the energy by a factor of 3 times 1 squared. Here I get 1 times 4 squared, which is 16. Here I get 3 times 2 squared, which is 12. And here I get 2 times 3 squared, which is 2 times 18. So then that would be C is the right answer. Gwen weighs 150 pounds, Amy weighs 50. They are standing still on ice and push off from one another. Amy goes away at 10 meters per second. What is Gwen's speed? All right, well, Gwen has 3 times the weight of Amy. She's 150 pounds while Amy's 50 pounds. That means she's going to go away at a slower rate. Right? In fact, she's going to go away at a rate that is 1/3 that of the velocity of Amy. So 10 divided by 3 is 3.3 or 3 meters per second. A is the right answer. A, 3 meters per second. And that's the end.